In this chapter, Chapter 8, we're going to be talking about a very important concept in music, the Overtone Series. The Overtone Series really serves as a basis for our entire understanding of Western musical scales. It helps to explain a lot of procedures that composers use to double chords. It explains concepts that are more advanced, like voice leading, which is basically the way that melodies tend to move in their most natural and, at least in the classical period, deemed to be desirable way. So the overtone series is a very important concept, and it's a good idea to take some time now to try and learn as much as you can about the overtone series. So by the end of this chapter, you should know about the overtone series, the intervals in the overtone series, the perfect major and minor intervals, the tempered system, and how you can actually hear overtones. At the very end of this, I'm going to post a video that will allow you to actually hear the overtones for yourself. So we have a few important terms that you should know before you even begin this chapter. These terms will make a little more sense once I actually get into the concept of the overtone series and explain to you what it is and show you some written notation. But for now, you should try and learn these terms. Just take a screenshot of this so that while you're watching the lecture, you can refer to these terms if you need to. So the first one is a fundamental. This is the bass tone in the overtone series. It's a pitch that produces all the pitches over the initial tone. Now that's not going to make a lot of sense to you yet until I actually explain what the overtone series is. But know that in the overtone series, we have different types of pitches. It's basically, if I play a tone, you hear a bunch of fainter tones above that, but it's not really perceptible by the ear. So the lowest tone, if I play a C on the piano, the tone that you're going to hear is the fundamental. And then there are these fainter notes that you actually hear above that low tone, known as partials. Now, a partial and an overtone are really the same thing except for one small distinction. A partial is any note in the overtone series, including the fundamental. So the fundamental is also a partial. They are labeled from the lowest to the highest tone present. An overtone is also any note in the overtone series, but it does not include the fundamental because they're tones over another tone. So they're tones over the fundamental. So to think of this a little more clearly, and this will make more sense when we actually get into an illustrative discussion of the overtone series, but the second partial is also the first overtone. So just kind of keep these terms in the back of your head. Know that we're going to talk about the fundamental, partial, and overtone in more detail. The final concept you want to understand is the tempered system. In our Western musical system, we have a scale that has been adjusted from nature to form 12 equally spaced pitches. As you know, on the piano, between C and B, we actually have 12 half steps. So at one point in history, these 12 half steps weren't equally spaced. Some were a little bit larger than others. Eventually what happened was, so that we could create more advanced music, we tempered the system so that every half step was equally spaced. In general, it refers to a process that adjusts the pitches in a scale to make them all the same distance apart. So just keep these terms in your mind and know that as I go through this lecture, these are terms you need to pay attention to when they come up. So the overtone series occurs naturally whenever a tone is played. So if you go to the piano and you pick any pitch, you're not just hearing the pitch that is being played, you're actually hearing a combination of several pitches above that the ear then condenses into one single tone that we recognize as being C4 or D4, whatever pitch you happen to play on the piano. In mathematics and physics, they usually refer to this concept of the overtone series as the harmonic series. And as I said at the end of the unit, an audio example of overtones will be provided. First of all, you should know that the Overtone series plays a crucial role in the development of our musical scale. While we weren't always certain the Overtone series existed, there was good evidence that it did exist, and it helped music theorists to develop the modern scales that we have today. So each tone that is played on an acoustic instrument. Remember, an acoustic instrument is an instrument that produces its own amplification of sound, such as a piano or violin. The voice is also an acoustic instrument. But whenever you play a tone on an acoustic instrument, a series of faint pitches known as overtones are also heard. And generally, because the fundamental tone, the note that you're actually hearing, is so powerful, you're not going to hear these fainter pitches. They reverberate at a much softer volume, so they're very difficult to hear. But there are some things you can do, especially on the piano, to make these overtones audible. So that's something you should know. The overtones are typically not audible, but various instruments can make them audible by employing particular techniques. And the brain condenses the tones into what sounds like a single pitch to our ears. So early musicians and scientists, they discovered that overtones existed, and they did this through a combination of experimentation, intuition, observation, and careful listening. There are a lot of stories about the development of the Overtone series. One is that a musician was walking past a blacksmith, and several anvils were being used to forge steel. And depending on the size of the anvil, it produced different pitches, and they were able to actually hear overtones, and that's where this whole idea came from. So whether or not that's true, it's not really certain. But there's a lot of legends about how the Overtone series and the concept of harmonics actually came into existence. That's one of them. So musicians weren't always certain that overtones existed, but the concept was useful for explaining a range of phenomena. Arnold Schoenberg was a composer and theorist who taught at UCLA, and the Schoenberg Music Building is actually named after him. He based his theoretical text, The Theory of Harmony, on the belief that overtones were a true phenomenon. So in the very beginning of his book, he discusses overtones and how they're useful for explaining why we arrived at the major scale, why the Western world arrived at the major and minor scales that we have today. And he says even if these aren't true, if the Overtone series is determined to be a falsehood, then it still serves the purpose of helping us to conceptualize why certain tones move one way or another. So the first 16 partials of the Overtone series, and actually all the partials of the Overtone series, they follow a ratio. But in this particular image, we've only listed the first 16 partials. When any note is played, it results in a series of pitches that follow a particular intervallic pattern. So the first pitch that you hear is an octave above the fundamental. So here you see the fundamental. There are two columns. The top one, the first layer, is overtones. The second layer says partials. So you can think about this in terms of overtones or partials. But if you play that bottom note, the bottom note is the fundamental. The first overtone, or the second partial that you hear above that fundamental, is known as an octave. So the first tone you actually hear is an octave higher. The next tone you hear is a perfect fifth. We call it a perfect fifth because it really doesn't have to be adjusted from the natural overtone series we hear in nature. Some of these partials you'll find have to be adjusted because they're out of tune. But the perfect intervals are perfect because they're so close to the fundamental and they really don't have to be adjusted at all. So the next interval above the second overtone, or the third partial, from the third to the fourth partial, is actually a perfect fourth. So now we have a perfect octave, a perfect fifth, and a perfect fourth. This is where the perfect intervals stop. After this, we have a major third, from the fourth to the fifth partial, where you see that E there from C to E, and then you have a minor third from the fifth to the sixth partial, and then another minor third from the sixth to the seventh partial. Now, this is a little more advanced, but for those of you that already understand the concept of chords, you'll instantly recognize that our major triad is formed from the 4th, 5th, and 6th partial. Additionally, the dominant 7 chord, which is a very important chord in music, is formed from the 4th, 5th, 6th, and 7th partial. So, if any of that is confusing to you, all you need to know is that the Overtone series consists of overtones and partials, which in many ways are the same thing. Overtones simply occur over the fundamental, and we start numbering them after the initial fundamental pitch. Partials include every single pitch in the Overtone series, including the fundamental. That's what you really need to be taken away from all this. Also, you should vaguely understand that the Overtone series serves as a basis for the creation of many of our chords and major and minor scales. If you keep going up the Overtone series, you'll see that it actually, the first occurrence of each note will actually spell a major scale. And then the notes in parentheses, like overtone 6 or partial 7, is actually a note that's really out of tune. Same with the F sharp there in overtone 10 or partial 11. So these are the notes that really don't fit our tempered system at all. They cause a lot of problems. The perfect octave, perfect fifth, perfect fourth, major third, and minor third are all important intervals in Western music. And that's really what I'm getting at here. Even if you don't understand how to calculate intervals yet, which you don't have to, I'm telling you that the Overtone series begins with these important intervals. There's 5 of them. The perfect octave, perfect fifth, perfect fourth, major third, and minor third. So if we go back to this scale, the first interval we have is a perfect octave. I'm just telling you that right now. The next interval is a perfect fifth, then a perfect fourth, then a major third, then a minor third. That sequence is important because the intervals that are closer to the fundamental are going to have a more powerful pull to the fundamental. They're going to have a more powerful relationship and resonance. So octaves create strong resonance. Perfect fifths create fairly strong resonance as well. Same with the perfect fourth. Major third and minor third, the further you get away from the fundamental, they start to lose some of their resonance to the fundamental, the Overtone series. But these intervals are used to create chords, including triad and 7th chords. So the closer the interval is to the fundamental, which the lowest tone in the series, the stronger the gravitational pull back to the fundamental. And you can think of it as a gravitational pull, but it's not as we would think of it in terms of the Earth and gravity and the Moon and gravity. However, the octave is so closely related to the fundamental that it's often considered to be the same note. If you play an octave on the piano, it really has kind of a hollow sound. It doesn't have a strong distinction between the lower and the higher note in the octave. A perfect fifth, you can start to hear the difference between the notes. In a perfect fourth, you can hear the difference even more strongly. So the further we get away from the initial intervals in the Overtone series, the more dissonant the intervals become, which is an important concept in music. We have consonant and dissonant intervals. Consonant intervals are ones that sound really open and airy and pleasant, and some might say. Dissonant intervals are going to sound more clashy and more like they're fighting each other. There's more contrast, and dissonant intervals they stand out more in the musical texture. So since the perfect interval, the perfect fifth, is considered one of the strongest intervals in Western musical systems, it ends up being an interval that just keeps coming back again and again. If you've ever heard of the 5-1 cadence, it's a very popular cadence in classical music and popular music. So the fifth is an important concept because it has so much relevance to the Overtone series, our chord progressions, the way we build chords, and even how we perceive scales, which you'll learn more about as we continue. But the perfect fourth is likely the second most important interval for creating harmonies, and the fourth is really just a perfect fifth played in reverse. If you again look at this, the perfect fourth is going to be from partial 2 to 3. So that is C to G going down. The perfect fifth goes from C up to G. So it's the same notes, but when you place the C below the G, you get a perfect fifth. When you place the C above the G, you get a perfect fourth. So they're very closely related for that reason. So this next point, C ascending to G is a perfect fifth, but G ascending to C is a perfect fourth. You reverse those and you get the opposite correlation. So the major third is an interval that occurs in major scales and major triads. These are the chords, the harmony that build a piece. This makes it an important interval and perhaps why it's called major. Now the minor third is slightly out of tune with the natural overtone series, which possibly made it less desirable to musicians in earlier times. Again, if you look at this, you see the B flat in parentheses, that is overtone 6 or partial 7. Because it's in parentheses, that's telling you that it's out of tune, and that's your first minor third. So this is possibly why minor scales are considered minor, and major scales are considered major, because the major scales fit more nicely and conveniently with the overtone series. So now I'm going to talk a little more about perfect, major, and minor intervals. You basically have 3 types of intervals in music. There's actually 5, but we're going to talk about 3 right now. Perfect and major intervals have the same basic consonant quality. They both sound major, but the difference between perfect and major is that perfect are going to be the notes that fall within the first 2 octaves of the fundamental. They're the closest intervals to the fundamental of the overtone series. Major and minor intervals occur later on in the overtone series, so they're not perfect, and they're usually tempered a little bit to make it fit a system where we have evenly spaced half steps. So the overtone series helps to explain then why there are perfect, major, and minor intervals. Perfect intervals kept their original position in the overtone series, and since they also occur within the first 2 octaves of the overtone series, they have a strong relationship to the fundamental. Major intervals still conform pretty well to the overtone series, but they are considered more remote to the fundamental, so they aren't considered perfect intervals. They are also more dissonant than the perfect intervals and have to be used carefully when building chords. The 4th to 5th partial is a major third and closely conforms to natural overtones. You can see that here, the 4th to the 5th partial, from C to E. That's a major third. It's pretty close to being in tune with the overtone series. The 8th to 15th partial is a major 7th and also closely conforms to natural overtones. So again, that's a major interval. If you go from the 8th to the 15th partial, from the C all the way up to the B natural. So all of these, the point that I'm making here is all these major intervals, they conform to natural overtones. The minor ones tend to be more out of tune. And because of that, this is why most music in the classical period uses major keys. Minor keys do occur, of course, but they are rarely the basis for a piece. Instead, minor keys are generally considered as departures from the major key. Most minor pieces are requiems and more depressing styles of music that you might want to provide a sense of longing or mourning, because they have this natural sort of dissonance with the overtones that create a more powerful, albeit slightly imperfect, relationship to the natural overtone series. So the 5th to the 6th partial is a minor third, but it occurs further down in the overtone series from the major third. The 8th to the 14th partial is a minor 6, but it has to be tempered from the original overtones. So now we have all of our intervals, and you may not know this yet, but we'll come back to this when we actually talk about intervals. But we have the perfect 5th, the perfect 4th, and the perfect octave. And then you see with the major intervals, you have the major third and the major seventh. And then with the minor intervals, we have the minor third and the minor sixth. And the relationship here is that perfect intervals are really close to the fundamental, major intervals closely conform to the natural overtones, and minor intervals have to be tempered since they're out of tune with our tempered system. We have to adjust the natural overtones to make them work. It can be seen that the only intervals that closely conform to the overtone series are the perfect unison, the perfect fourth, the perfect fifth, and the perfect octave. These intervals did not have to be tempered from the natural overtone series to make our system work. In earlier music, many instruments could only play the notes that emanated from the overtone series. This made it hard for these instruments to play along with dissimilar instruments. So the solution was to temper the system so we could have large orchestra forces that were able to play really complex music with very strong and resonant chords. So the solution involved coming to a consensus about how many notes to include in our octave. Then we adjusted the pitches so they were spaced in equal distance from each other. It resulted in our chromatic scale, which you'll learn about later, that uses a series of half steps. We've already discussed the concept of the chromatic scale, but you haven't actually seen it written out yet, so we're going to get more into the chromatic scale later on as we go. So the next best option is widely considered to be a 53-note scale within the span of an octave. But if you've ever had to practice your scales, you know that a 53-note scale is quite a task. 12 notes by itself is enough to make music majors lose their mind when you have to practice all 12 major scales. So, and there's actually 15 of them if you count the enharmonics. So a 53-note scale within the span of an octave would just be unmanageable. And a true system that actually conforms to the overtone series would require more than 3,000 notes in an octave. But the upside is you could basically compose the sound of thunder. So our system is a compromise. It's a 12-note compromise that works on the majority of instruments that we have developed. If new instruments were developed, it's possible that maybe a 53-note scale could start to become a reality. And with electronic music, that does open some doors that weren't previously available to composers who want to start composing more advanced music that uses more notes than our traditional system. So the tempered system is a compromise that provides a reasonable number of equally spaced pitches in an octave while still keeping the perfect intervals that occur at the beginning of the overtone series true to their original tones. So it is all about compromise. Which notes are we going to have to modify and which ones can we keep? And they said, let's keep the perfect pitches that we have, the perfect fifth, the perfect octave, and the perfect fourth, and then adjust everything else around that. As you should know by now, the Overtone series consists of several unique intervals that repeat in a ratio. So the first note in our Overtone series, if we're going to start with the note C, if this is a fundamental, I play that, it's going to play a series of tones above that, more subtly, and then the ear combines all these tones into a single note that we hear. But there's a way to separate these tones out so that we can hear them more clearly. So if you remember, the first interval in the overtone series is an octave right here. Then you hear a perfect fifth. Then there's a perfect fourth above that, which is our C again. And then we have a major third. So those are your initial tones in the overtone series. Now you can hear them very clearly because I played them. But if I simply depress the keys so the hammers are resting on the strings and they don't make any noise, if I hit this fundamental tone, what's going to happen is you're going to hear these other pitches resonate with the fundamental. It's a very subtle ringing. time. Now, if I were to choose notes that aren't within the first couple octaves of the Overtone series, we consider those more remote overtones. So let's choose D, A, and we'll just reinforce the D of the octave. Now I'm going to play the fundamental again, and it's not going to ring as long. The sound dies out right away, as opposed to this. You got to push them down slowly, otherwise you'll make a sound. All right. That's the overtones that are close to the fundamental. And here are the ones that are further away. No sound at all. So that's an important concept in Western music, and I'm going to talk more about that now.